Hello everyone. In this video, we will discuss test 2 question paper. So first question is write algorithm for decision tree induction. So here's follows the decision tree algorithm. Step 1, begin the tree with the root node, say S, which contain the complete data set. Step 2, find best attribute in data set using attribute selection measure. Step 3, divide the S into subset that contain possible value for the best attribute. Step 4, generate decision tree node, which contain the best attribute. Step 5, recursively make new decision tree using the subset of the dataset created in step 3. Continue this process until a stage is reached where you cannot further classify the node and call the final node as a leaf. So this is the algorithm for decision tree. Now, next question. Next question is, what is attribute selection measures? Explain three of them. Recording in progress. So, attribute selection measures. Construction of decision tree. A tree can be learned by splitting the source set into subset based on attribute selection measure. Attribute selection measure is a criterion used in decision tree algorithm to evaluate the usefulness of different attributes for splitting a dataset. The goal of ASM is to identify the attribute that will create the most homogeneous subset of data after the split, thereby maximizing the information gain. This process is repeated on each derived subset in a recursive manner called recursive partitioning. The recursion is completed when the subset at the node all has the same value of the target variable, or when splitting no longer add value to the prediction. The construction of decision tree classifier does not require any domain knowledge or parameter setting and therefore is appropriate for exploratory knowledge discovery. Decision tree can be handled high dimension data. So first way of attribute selection is entropy. Entropy is the measure of the degree of randomness or uncertainty in the dataset. In the case of classification, it measures the randomness based on the distribution of class label in datasets. The entropy of a subset of a original dataset having k number of classes for the ith node can be defined as where S is the subset sample, k is the particular class from k classes, P of k is proportion of the data point that belongs to class k to total number of data points in the dataset sample S. Here P of I, k should not be equal to 0. Important points related to entropy. The entropy is 0 when data set is completely homogeneous, meaning that each instance belongs to same class. It is the lowest entropy indicating no uncertainty in the dataset sample. When dataset is equal divided between multiple classes, the entropy is at its maximum value. Therefore, entropy is highest when the distribution of class level is even, indicating maximum uncertainty in the dataset sample. Entropy is not used to evaluate the quality of split. The goal of entropy is to select the attribute that maximize the entropy of the resulting subset by splitting the dataset into more homogeneous subset with respect to class labels. The highest information gain attribute is chosen as the splitting criteria. Reduction in entropy after splitting on that attribute, and the process is repeated recursively to build decision tree. Second is Gini index. Gini impurity is a score that evaluates how accurate a split is among the classified group. The Gini impurity evaluates a score in range between 0 and 1, where 0 is when all observation belong to one class and 1 is the random distribution of element within the class. In this case, we want to have Gini index score as low as possible. Gini index is the evaluation metric we shall use to evaluate our decision tree model. Here, Pi is the proportion of element in the set that belongs to ith category. Next is information gain. Information gain measure the reduction in entropy or variance that result from splitting a dataset based on a specific property. It is used in decision tree algorithm to determine the usefulness of the feature by partitioning the dataset into more homogeneous subset with respect to class labels or target variable. The higher the information gain, the more valuable the feature in the predicting the target variable. The information gain of an attribute A with respect to dataset H is calculated as where A is specific attribute or class label, H is the entropy of dataset sample S, and where HV is the number of instance in the subset S that have valued V for attribute A. Information gain measure the reduction in entropy or variance achieved by partitioning the dataset or attribute. The attribute that maximizes information gain is chosen as the splitting criteria for building the decision tree. Information gain is used in both classification and regression decision tree. In classification, entropy is used as a measure of impurity, while in regression, variance is used as a measure of impurity. The information gate calculation remains same in both cases except that entropy or variance is used instead of entropy in the formula. That's all for this question. Now next question. Next question is define and mathematical expression of information gain, Gini index, reduction in impurity. So we have seen the definition of each one of it. Now we will see mathematical expression for each of it. So mathematical expression for information gain is this: h of s equals to minus summation I to n p of I log base 2 p of I. And mathematical expression of Gini index is 1 minus summation I to n p of I whole square. And mathematical expression for reduction in impurity is E is equals to minus summation I to n p of I log base 2 p of I. These both are same and it is also called entropy. That's all for this question. Next question. Next question is explain concept of overfitting and tree pruning. So overfitting means too many unnecessary branches in the tree. Overfitting result in different kind of anomalies that are result of outlier and noises. How to avoid overfitting? There are two techniques to avoid overfitting: pre-pruning and post-pruning. Pre-pruning means to stop the growing tree before the tree is fully grown, and post-pruning means to allow the tree to grow with no size limit. After tree completion, start to prune the tree. Advantage of tree pruning and post-pruning: pruning control to increase the unnecessary tree. Pruning reduce the complexity of the tree. So this is the concept of overfitting and tree pruning. That's all for this video. Thank you.